Hi, my name is Ron Wade. I am a system architect in the timing products division of Renesas Electronics, and I'm here today to add PCI Express Gen 7 to our comparison of PCIe common clock filters with the 12 kilohertz to 20 megahertz brick wall filter. So here we have the brick wall filter in brown. It's pretty simple. Between the 12 kilohertz and 20 megahertz, we have essentially no attenuation whatsoever. The pass band, if you want to call it, is at 0 dBc. So everything within that range is passed through or transferred to the output. The PCIe common clock filters are very different, though. In red here we have the PCI Express Gen 3 and 4 common clock filters. There are 64 different ones hiding out in that blob of lines. And you can see that essentially from 1 megahertz and below, there is an attenuation of any input phase noise that would be occurring in those frequency ranges. From 1 megahertz and above, there is still an attenuation, but it is at a much less attenuation than below 1 megahertz. So we can see that from a transfer function, any jitter on a reference clock that is above 1 megahertz, any phase noise that is above 1 megahertz will be more highly transferred to the output, and so will have a larger impact on the jitter result. And that's true for Gen 5 and Gen 6 and now Gen 7. Gen 7 here is according to the latest 0.7 specification in the SIG. But the general theme here is that as we go up in speed from Gen 3.4 to 5.6.7, the peak above 1 megahertz goes down, and the attenuation below 1 megahertz is increased. But the net result is still 1 megahertz and above is where most of the input jitter from the reference clock will be transferred to the output. So we can say that PCI Express is most sensitive to phase jitter on its reference clocks that is above 1 megahertz. So that concludes today's little chat on PCI Express filters, and there will be more coming soon. So thank you for watching.